Welcome to Pure 1, Chapter 11.2, where we look at representing vectors. Now, this is probably new from GCSE, where we look into a different way of to write vectors. So there are two ways to represent vectors. One way is what you've learned GCSE way, which is what we call the column vector form, and the other one is called the IJ form. So let's look at the column vector form. So let's say you've got in here. Let's say here's a vector, okay? We do a 5 and a 3 in here, okay? So let's call this A. So then we call A equals to 5, 3, because we do 5 right and 3 up. So 5 right and 3 up, therefore 5, 3, right? So that's what you've done in GCSE, column vector, like a translation. Move to 5, 5 to right, 3 up, so 5, 3. And if we have, let's say, another one, which is that way, okay, let's call this B, and this time we've got, now to go that bottom left, we go left in here, let's say 4 and 6 in here, then you could imagine B will equal to B will equal to minus 6 minus 4, because 6 left and then 4 down. Okay, so 6 left, 4 down. So that's what we call a 6 left, 4 down. So that's column vector form, like a translation vector. Okay, right. Another one is called the IJ form, new thing. So unit vector I represents 1, 0, and the J represents 0, 1. So if you think about in a axis, okay, pair of axes, okay, then I essentially is the vector here. That's I. So this is I, which is 1, 0. And J is the one pointing, oops. And the J is the one pointing here, which is 0, 1. So how do we write it? Well, if we use A and B, same thing left hand side in here. Okay, so A equals to, well, we know A equals 5, 3. Okay, so if we break it down, we can make it 5 times 1, 0 plus 3 times 0, 1. Because if you try to multiply across, 5 times 1 is 5, 3 times 1 is 3, so 5, 3. That gives us 5i plus 3j. So about B? B, if we have minus 6 minus 4, minus 6 minus 4, that becomes negative 6 of, whoops, that becomes negative 6 of 1, 0 minus 4 lots of 0, 1. So minus 6i minus 4j. Don't get it? I'll give you a few more. Let's say we've got a vector C in here, which is 4 minus 3. So you probably know is 4 times 1, 0 minus 3 times 0, 1, which is 4i minus 3j. Last one, what about 0, 5? 0, 5 is the same as 0 plus 5 times 0, 1, which is just 5j. Okay, so do we need a middle step? No, we don't. If I give you one more E, for example, in here, let's say I've got a 2 minus 4, then I can quickly rewrite 2i minus 4j. The top number essentially represent I, and the bottom number represent j. Okay, so yeah. Right. Example, if A equals 6i minus 9j. So think about this, okay? Before we start, okay, just to get you used to using I and j. Now, if we start from the origin, where is the vector 6i minus 9j pointing? So 6i minus 9j is 6 to the right and 9 downwards. So that will be this way. Okay, so that's A. Okay, just a bit of give you an idea where 6i minus 9j. And B is 12i plus 6j. So 12 to the right, 6 up, probably like this. That's B. This diagram is not relevant. Part A, find a half A. So a half A equals a half times 6i minus 9j, like expanding bracket, 3i minus 9 over 2j. So you can write 9 over 2j, or you can write 4.5j. There's no fixed rule on what number you have to write in front. It can be a fraction, it could be decimal. If it's a ugly decimal, you should write as a fraction. Okay, part B, 2a minus 5b is the same as 2 times 6i minus 9j minus 5b, minus 5 times 12i plus 6j. So if I expand the bracket, that's 12i minus 18j minus 60i minus 30j. So that gives me 12i minus 60i is minus 48i minus 18, that minus 48j. Oh, minus 48i minus 48j. So both numbers are strangely, coincidentally, equal. No reason. Practice question one. Okay, pause the video. Okay, have a go at the question. Now, some numbers will be in decimal, some number will be in vector form. Okay. Oh, by the way, before we actually move on, so this one you can also rewrite as 3 minus 4.5. You should prefer. Okay, this one will be minus 48, minus 48. So pause video, have a go at question one. Okay, when you're ready for the answer, you can press play. So here are the answers. Okay, you can either leave them in column vector form or ij form. In the question, if they want you to give it a specific format, they will tell you leave it as column vector form or leave it in ij form. So you will see. So I've written both answers. You can write both of them, either one of them. Okay, so that's A, B, C, and D. Okay, right, let's move on. Example, given that C equals 3i plus 4j and D equals I minus 2j, find lambda if C plus lambda D is parallel to I plus 2j. Now, before we start, okay, I want you to think about parallel, the word parallel. If two vectors are parallel, obviously we know the vector form will be sort of one with multiple another. Or if we think about as a line, okay, as a line, when you say two lines are equal, or sorry, two lines are parallel, means their gradient is the same. Okay, so parallel means vector, not gradient. So either vector is a multiple of another. Sorry about my scribbling, because I've run out of space to write. Or another, or okay, you can say the gradients are equal. Now, question is, how do we find the gradient of a vector? Now, think about this. If I give you a 3i plus 4j, okay, a 3 and a 4, okay, so this A is 3i plus 4j. Can you work out the gradient for this line? How would you work out the gradient of this line? The gradient will equals to 4 over 3 because the vertical component, difference of y over difference in x, essentially that's the j component over the I component. It's the coefficient of the j over the coefficient of the I. Okay, we'll come back to this. So part A. So C plus lambda is parallel. So C plus lambda D is parallel to I plus 2j. So let's work out C plus lambda D first in terms of lambda. So C plus lambda D, C is 3i plus 4j plus lambda D plus lambda I minus 2j. Now, some people prefer to write an I and j. Okay, some people like to use column vector. The benefit of writing a column vector is you can write quite neatly because if you look at the previous conversation, do we have a conversation? Maybe we don't, maybe we do. Practice question one, the calculation. We can see using column vectors a lot easier to calculate because you can just work out the sum in top row and then work it out and work out the sum of the bottom row. So whereas I and J, sometimes if you write your I like a J or J like an I, you might mix it up, etc. So right, so I'll show you both ways. So if I use I and J form, that will be 3i plus 4j expanded bracket plus lambda I minus 2 lambda j. What I'll do in here is I'll factorize the I form, the i's. Okay, so factorize the i's. So 3 plus lambda I and factorize j, 4 minus 2 lambda j. Or you can use column vector form. So it's not required, just showing you 3, 4 plus lambda of 1 minus 2. 3i plus 4j is 3, 4. I minus 2j is 1 minus 2. So if you multiply it, so 3, 4 plus lambda minus 2 lambda, that's the same as 3 lambda and 4 minus 2 lambda. Okay, so 3 plus lambda, so 3 plus lambda. Okay, right. So when we say they're parallel, okay, so what's the gradient of this line? So the gradient of C plus lambda D equals to 4 minus 2 lambda over 3 plus lambda. Because we do the J component of the vector. Look at this one, 4 over 3. So it's J is the coefficient of J over the coefficient of I. So you might want to write down here. That's the coefficient of J. And this is the coefficient of I. Okay, now your turn. What about the gradient of I plus 2j? That will be 2 over 1. The j component, the coefficient of j over the coefficient of I. So what do we know about their parallel? If they're parallel, it means they're equal. So we can, the next step, we can write 4 minus 2 lambda over 3 plus lambda equals 2. Now, different way, people will teach you different things. When they parallel, some people also like to use the method number one where vectors multiple of another, which I'm not going to show you in here. So this is my way of working. When you told two vectors are parallel of each other, we can use the gradient. So in here, what I do is I sort of cross multiply. Think about 2 over 1 cross multiply becomes 1 times 4 minus 2, 1 times 4 minus 2 lambda, same as 4 minus 2 lambda, 2 times 3 plus lambda. Expand the bracket on the right hand side, 6 plus 2 lambda. So that becomes 4 lambda equals minus 2. Is it minus 2? Yep, lambda equals to minus half. That's the answer. Okay, so that's the answer. Right. And yep, just checking the answer. Right. Part B. Okay, let's do part B. So very similarly, okay, I'm going to show you one more. Example, given that this time mu c minus d is parallel to this. So we can do this. So what we can now know is the gradient of minus 4i plus 3j is 3 over minus 4. So what about mu c minus d? So mu c minus d, before we can work out the gradient, let's simplify the vector. So mu times c, 3i plus 4j, minus d, minus I minus 2j. So expand the bracket, 3 mu I plus 4 mu j, minus I plus 2j, minus minus makes a plus. Factorize the i's, 3 mu minus 1 I plus 4 mu plus 2j. Now, when we write I and j, when you sort of factorize them, you're not actually factorizing, you're just grouping up together. When you want, let's call it factorize for now. If you want to factorize it, you must put an I at the end because I is a conventional way of writing a vector where I and j must be placed at the end. It's like a direction. 4 left, 4 right. No, you can say left 4, but we in the maths it's like we're saying 4 then left. So the magnitude first, then the direction. Okay. And a gradient. So the gradient equals to 4 mu plus 2 over 3 mu minus 1. So what do we know? Well, we know they're parallel, so therefore we can make them equal. Multiply minus 4 across, so minus 4 times 4 mu plus 2 equals 3 times 3 mu minus 1. So minus 16 mu minus 8 equals 9 mu minus 3. That's 25 mu. That's minus 5, I believe. So mu equals to negative a fifth. Okay, and that's the answer. All right. Anything else? Yep. So your turn. Okay. Pause the video. Have a go at practice question 2. When you're ready for the answer, you can press play. So here's the answer for A and B. Okay, so question A, I work out C plus lambda D first. I simplify them into 2 plus lambda I plus 1 minus 5 lambda J, 5 lambda J. So you can check your final answer, and if it doesn't right, then you can check your vector first, and then check your equation, see if you equate them properly. So 1 minus 5 lambda is a J component, or the, what do we call it? Yeah, the coefficient of j over the coefficient of I. So sometimes I call it I component, sometimes I call it j component, or the some call it I component, sometimes call it coefficient of I. So whichever way you get it. So it's the 1 minus 5 lambda over 2 plus lambda equals 3 over 2 because there's a gradient of 2i plus 3j. It's the coefficient of j over coefficient of I. Cross multiply them, simplify the algebra, you should get minus 4 over 13. So same with B, and here's the answer. Okay. Right, so exam practice. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Okay, probably I've not explained. Resultant of the vectors, in case you don't know, the resultant vectors, when we say resultant, means you will do A plus B. So resultant vectors, same as sum, add them up together. Okay, so resultant vectors, A and B, that means A plus B is parallel to C. Okay, so hopefully that gives a bit of clarification. Pause the video, have a go. Here are final answers. Okay, so A plus B, do the same thing. Simplify it, factorize the I, make it 191j, and then do the gradient of A plus B over the gradient of 4i minus 5j, and then, yeah, make them equal. P equals 5 to find resultant vector. A plus B, sub in 5 into here, and you get 16i minus 20j. And I believe that's it for 11.2.